Good morning, students. Now we are going to revise the lesson Semiconductor Electronics. First we will see what is meaning of forbidden energy gap. What is forbidden energy gap? The gap between the valence band and the conduction band. That is called forbidden energy gap. What is valence band? Valence band is consists of valence electrons. It's never be empty. It is partly filled or completely filled. Conduction band consists of charge carriers. Maximum it is empty. The electrons or the holes are shifted from the valence band to the conduction band when the external field is applied. Okay. The energy gap between valence band and the conduction band is called forbidden energy gap. With the help of the forbidden energy gap, the materials are divided into three. The first one is conductors. Next is semiconductors. And the last one is insulators. What is conductors? The valence band and the conduction band both are overlapping here. The forbidden energy gap value is equal to 0 for conductors. The second one is semiconductors. The forbidden energy gap value is very less than 3 electron volt. You see, the gap between the valence band and the conduction band is narrow here. So that is semiconductor. The last one is insulator. The forbidden energy gap is very greater than 6 electron volt. For glass you are taking means that value is equal to 10 electron volt. Like this high value is there means that is called insulators. So with the help of the forbidden energy gap you are dividing the material conductors, semiconductors and insulators. Now what are the types of conductors? The first one is intrinsic semiconductor. Second one is extrinsic semiconductor. What is meant by intrinsic semiconductor? The purest form of the semiconductor is called intrinsic semiconductor. Example, pure germanium, pure silicon is an example for intrinsic semiconductor. What is meant by extrinsic semiconductor? You are adding impurity to the intrinsic semiconductor. So the impurity what you are adding, that is called what? Dopant. The process of adding impurity to the intrinsic semiconductor is called doping. How much you will add? Only 100 ppm, parts per million is allowed to add. This is called extrinsic semiconductor. This extrinsic semiconductor is divided into two. The first one is P-type semiconductor. When P-type semiconductor means you are adding trivalent impurity. Trivalent means only 3 valence electrons are there. You see the diagram here, boron or gallium is added. In the germanium or silicon, the outermost element, the valence electrons value is equal to 4. So here only 3 trivalent impurity you are adding. So one hole or the one vacancy is there. So that is called which one? P-type of semiconductor. So it accepts the electron from the neighbor one. So this is called acceptor level. This acceptor level is present near the valence band. Okay, so this is a valence band, this is a conduction band, means the acceptor energy level is present near the valence band. This is P-type of semiconductor. The next one is N-type semiconductor. What is meant by N-type semiconductor? You are adding a pentavalent element. When you are adding pentavalent phosphorus like this, you are adding a pentavalent here means now this forms a covalent bond with the germanium or silicon atom. So remaining one more electron is there. That is a free electron. So this free electron that donates the atom to the neighboring one. So this N-type semiconductor is called donor. So if the donor energy level is present, this is a valence band, This is a conduction band. So the donor energy level is present near the conduction band. So P-type semiconductor means you are adding trivalent. N-type means you are adding a pentavalent. P-type is a acceptor one and N-type is a donor. It donates the electrons. Now, the next one, how the P-N junction is formed. When P-type semiconductor and N-type semiconductor is joined means the P-N junction is formed here. In a N-type semiconductor, what is the majority charge carriers? Electron is a charge, majority charge carriers. The holes are present very less amount. In the P-type of semiconductor, which is a majority charge carriers, holes is a majority charge carriers, electron is very less it is. When both are joined means the electrons are crossing the junction. More number of electrons are crossing from the N-type semiconductor to P-type semiconductor. Same way, in the P-type side, number of holes are there, more number of holes are there. That crossing the junction from P-type to N-type. So, near the junction, near the B-N junction, the depletion region is formed. What is meant by depletion region? The immobile charges are present here. See, the number of positive and the number of negatives are equal. So, no charge here. So, the depletion region is formed in this side. Okay, when you are applying the external potential, external electric field here means number of electrons are crossing the junction is greater. So the potential barrier is produced here. When you are applying the positive, the potential is greater. Negative, the potential is less. So the movement of electrons in this side, this is P-N junction formation. Now, how you are representing the P-N junction diode? See, the triangle represents the positive end of the diode. The line represents the negative end of the diode. Positive means it is anode and negative means it is cathode. So, when P-type and N-type semiconductor join means that is called what? P-N diode. This is a symbol for P-N diode. Now, in the biasing side, two type of biasings are there. What is meant by biasing? Providing external energy to charge carriers to overcome the barrier potential, that is called which one? Moving in a particular direction, that is called biasing. Biasing a diode. Two type of biasing is possible. One is a forward bias. When you will tell it is a forward bias, P-type of semiconductor is connected to the positive end of the battery. N-type of semiconductor is connected to the negative end of the battery. When positive, positive, negative, negative is connected means it is forward bias. More number of holes are crossing, more number of electrons are crossing. The width of the depletion region is decreasing. This is forward bias. What is meant by reverse bias? P-type semiconductor is connected to the negative end of the battery. N-type connected to the positive end of the battery. So, number of electrons and the holes are crossing the junction is very less. So, the depletion region is, the width of the depletion region is greater. The current value is very less. Sometimes the value is equal to 0. The current is measured in terms of microampere. The width of the depletion region is greater in the reverse bias. Okay, now what is meant by rectification? The process of converting alternating current to direct current or alternating voltage to direct voltage, that is called rectification. The device used for the process is called rectifier. Two types of rectifier is here. One is half-wave rectifier, another one is full-wave rectifier. Half of the wave is rectified means that is called half-wave rectifier. What are the components are here? This is the input signal. Okay. Now only the half of the voltage is rectified. Since this is a positive one, how many components are here? Transformer, diode and the load resistance in the half-wave rectifier. When I am applying the positive voltage, only the wave is rectified. When you are applying the negative voltage, the diode won't conduct the electrons, that won't allow the electrons. So you won't get any output voltage, 0 only. Again you are applying the positive means you will get, so only the half of the wave is rectified. It is called half-wave rectifier. The efficiency value is in the half-wave rectifier is 40.6%. Then what is meant by full wave rectifier? The full wave rectifier consists of a center tapped transformer. So one time D1 is conducting means D2 value is 0. Then the second case, when you are applying the positive, D1 is positive, so it allow the current. D2 won't allow. When you are applying the negative, this one is allowing, D2 is allowing the current and D1 is not allowing. So when you are applying the positive or the negative voltage, both the times you are getting the output voltage. So it is called full wave rectifier. The efficiency is 2 times of half wave rectifier. So the efficiency value is equal to 81.2%. Okay, now the next one, this is a Zener diode, representation of the Zener diode, like the same way forward bias in the junction diode side. Now the next one is light emitting diode. This is a representation of the light emitting diode, light emitting. So that emits the light. So electrical energy is converted into light energy in the light emitting diode. The next one is photodiode. You see the difference in both the sides. The arrow mark is now here towards. So the light energy is converted into electrical energy, means that is called what? Photodiode. Now, the next heading is transistor, bipolar junction transistor. Totally 3 basic terminals are here. Emitter, the next one is base, the next one is collector. 2 type of transistor. One is a PNP transistor, another one is a NPN transistor. So when it is current flow from the positive to negative, you see then the NPN transistor, the current is moving from base to emitter outside. But the PNP transistor, current direction is towards the junction. So 2 type of transistor, NPN and another one is PNP transistor. When you are comparing the, which one? When you are comparing the emitter base collector, emitter is heavily doped and base is lightly doped. Collector also heavily doped because it receives the charges, charge carriers, majority charge carriers. Okay, now the next one is transistor circuit configuration. 3 type of configuration is here. One is common base configuration, common emitter configuration, common collector configuration. Common, that word refers, that is common for both the input and output side. That is common base. The base junction is, base terminal is common for both input side and the output side. That is common base. Common emitter. Emitter terminal is common for both the input and the output side. That is common emitter. The next one is common collector. Common collector means the collector junction is common for both the input and the output side. That is common collector configuration. The next one is static characteristics of a transistor. What is totally three types of characteristics you are prepared in this side. Input characteristics, output characteristics and transfer characteristics. What is input characteristics? You are drawing a curve in between base emitter voltage to the base current. So when you are drawing a curve slope this side and you are calculating the value of input impedance Ri value equal to change in base emitter voltage to the base current. What is the unit of this input impedance? The unit of input impedance is ohm. The next one is output characteristic side. Output characteristic side, you are calculated the value of RO. What is RO? Output impedance. Drawing a curve in between VCE and IC. So the ratio of VCE to IC, that gives the value of output impedance. The unit is equal to ohm. The output character is divided into 3 region. One is a saturation region, another one is a active region, and third one is a cutoff region. Below IB value equal to 0, that region is called cutoff region. The constant one, this is called active region. This rapid portion, this is called what? Saturation region. Okay, now the next one is which one? Transfer characteristics. In the transfer characteristics, you are drawing a curve in between IB base current and the collector current, and here you are calculating the value of current gain beta value is equal to IC divided by IB. For this current gain, no unit because both are in terms of ampere, so no unit here. Then how the transistor that act as an amplifier. What is mean by amplifier? Amplification is a process of increasing the signal strength, that is called amplifier. Increasing the amplitude, that is amplifier. Okay, the next one, how it is act as a, when it is act as a oscillator. Oscillator means what? That converts DC energy into AC energy of high frequency ranging from few hertz to several megahertz, that is oscillator. What are the components in the oscillator side? This is both L inductance and the capacitance are connected in parallel, that is called tank circuit. And the next component is amplifier, and the third one is feedback network. What is mean by feedback network? The fraction of output is fed into the input side. Sometimes the amplification is not enough, so the fraction of output is fed into the input side, that is called feedback. Two type of feedback is there. One is a positive feedback, another one is a negative feedback. Okay, then next one, the last heading about what you are prepared is logic gates. What is mean by logic gate? It's a electronic circuit which functions based on the digital signal, that is called logic gates. With the help of truth table, you are verifying all the 6 gates. Totally how many gates are there here? So first one is OR gate. What is OR gate? The OR gate add and give the value. So the output of the OR gate value is equal to A plus B. Okay, 2 input you are giving. So this is 2 input OR gate. You see the input combination is 0 0 0 1 1 0 1 1. When any one input is 1 or both the inputs are 1, you will get the high voltage, high value. High means what? High value. Otherwise you will tell it is a true value, or the voltage, applying voltage value equal to 5 or represented by 1. These. So you see the input voltage 0 0 0 1 1 0 or 1 1. If any one input is 1 or both the input are 1, you will get the output voltage. This is 2 input OR gate. You see the next one is AND gate. What is AND gate? The AND gate multiple and give the value A into B. OR gate that add and give the value Y value equal to A plus B. AND gate that multiple and give the value. You see, when any one input is 1 means you will get 0, or both the inputs are 0 also, you won't get the output voltage. If both the inputs are 1 only, you will get the output voltage. This is a symbolic representation of symbol for AND gate. Okay, now the next one, NOT gate. What is NOT gate? NOT gate is an inverter. When you are applying 0, you will get the output voltage value equal to 1. When you are applying the input voltage is 1, the output voltage is equal to 0. This is a symbol for NOT gate. Only one input, you will get the output voltage, only one output voltage. Y value equal to A bar. This is NOT gate. The next is NAND gate. What is NAND gate? This is a symbol for NAND gate. You see 0 0, you will get the 1 high output voltage. If both the inputs are 0 or any one input is 0, you will get the output voltage, high output voltage. If both the inputs are 1 means the output value is equal to 0. This is NAND gate. Now the next one is XOR. XOR gate. What is XOR gate? This is a symbol for XOR gate. The formula is Y value equal to A XOR B. What is the meaning of A XOR B? A B bar plus B A bar. In the XOR gate side, if any one input is 1 means 0 1 or 1 0, like this way means you will get the output voltage. When both the inputs are 0 means the output voltage is also 0. Same means 0 0 or 1 1 means the output value is equal to 0. This is XOR gate. The last one is NOR gate. This is a representation of a NOR gate. What is the formula for NOR gate? Y value equal to, it is the inverse of which one? Inverse of OR gate. complement of inverter, that means complement of OR gate. So A plus B the whole bar. Now 0 0 means 1, the remaining all the values you will get the value 0, output voltage value is equal to 0. If both are 1 or any one input is 1 means the output voltage value equal to 0. This is which gate? NOR gate. NOR gate and NAND gate. NAND gate formula is A into B the whole bar. These two gates are called universal gate because this consists of all the three basic gate: OR gate, AND gate and NOT gate. Now the last one is De Morgan theorem. What is De Morgan theorem? You see two theorems. The first one is the complement of the sum is equal to product of complement. This is the first theorem. The second one, complement of the product is equal to sum of the complement. This is the second theorem. With the help of the truth table, easily we will verify De Morgan first theorem and De Morgan second theorem. Students, this class you have learned about semiconductor, P-type semiconductor and N-type semiconductor, and all the gates logic gates you are prepared. Revise the lesson and write the test. Thank you, students.